Today I'll be finding the volume of a sphere, and I'm gonna do that. It's actually pretty lengthy, more lengthy than I expected. But I'm gonna do that by putting a sphere where its origin is on the origin is in the middle of the sphere. So it will be a Cartesian plane like this. So we're gonna split this sphere up into multiple cylinders, right? And each of these cylinders will have a height of dx and a area of, well, pi y squared. And hopefully this should be obvious that if on a plane here, that the area this would be the radius, in fact, that would be y, and then a tiny change in distance would be the height of the cylinder we're taking into account here. So in the end would be, the volume would be pi y squared dx. That's the volume of each cylinder, all right? And furthermore, the outer boundary of this sphere here is determined by the formula r squared equals x squared plus y squared. And you should know this formula is the formula of the circle. And without further ado, let's begin the integral. So the integral would be a sum of all of these cylinders, right? So it'll just be from, I'll explain later why I'm taking a limit from 0 to r, so pi y squared dx times 2. So basically, 0 to r would take into account from here to here, and I'm doubling it because since this sphere is symmetrical about both sides, all I have to do is find the volume of one side, and then I double it to get the volume of the full sphere, all right? So that's what the 2 times, what the 2 times means. All right, now we're at a problem. We can't have 2 variables within the same integral. So we have to find a way to remove this dx, which is actually pretty simple. We set x squared equal r squared minus y squared. We root everything. Furthermore, we take a derivative. Dx equals, well, let me do this in my head, negative y over r squared minus y squared, because the 1/2 and the 2 cancel out. All right, and we can just plug in dx here. So we get 2 to 0r pi y squared, forgot the dy, times negative y dy over root r squared minus y squared, right? And now we're at a really tricky integral. So we have to use u substitution. So let's define u as r squared minus y squared, right? And y squared would be r squared minus u, and 2y dy would equal, let me think, negative du. All right. So should I start a new page? No, let's just start in here, from here to here. All right. So first we're gonna plug this in. So we get 2, so u equal r squared minus y squared. So 2, and I'm going to take this pi out because it's annoying. Combine the negative y cubed dy root u, all right? And furthermore, y squared equals r squared minus u. So we can plug this y into here. We get 2 pi 0r root u dy times negative y r squared minus u. I removed the y squared. And finally, let me see, this negative y dy, well, y dy equals, or negative y dy equals du over 2. And let me revise my work here, or review my work. Yeah, I think this is correct. So we plug this negative y dy into here. We get, oh my, what's going on here? We get 2 pi 0 to r times, no, oh god damn it, that r is part of the limit. Then it would be r squared minus u du over 2 times root u. All right, now we have our integral here. And let's take this 2 out here. So 2 would cancel out with that 2, and then we just get, let me think, yeah, 2 pi from 0 to r r squared minus u du root u. We can split this up. So we get pi 0 to r squared over root u minus u over root u, and u over root u is just root u. And once we take this integral, or I'll just simplify it. So this just equals root u. We take an integral, and it's actually a pretty simple integral. Oh, by the way, these limits are wrong, but we're going to change it back to r later on. So just keep in mind that these limits are wrong. So it would be r squared. Just r squared is just a constant, so it doesn't really matter. 2u times 2, I think. Let me see. If we move it up, yeah, it would be 2. Minus root u would be u to 1.5 over 1.5. Yeah. Oh, we already taken an integral. We don't need this limit here. God damn it, I'm making so many mistakes. So pi times from 0 to r. Alright. And finally, we substitute u back for, well, r squared minus y squared. So pi times 2r squared minus y squared. Zero to r. Alright? Then we plug in r's here. Luckily, when we plug in r into here, we get 0, because r squared minus r squared is 0. But when we plug in r into here, we get, well, we also get 0. That's convenient, so 0. And then when we plug 0 in, we get r squared, root r squared, which is r, so 2r cubed. 2 pi r cubed. Here, negative, because it's the bottom part of the limit. And this would be r cubed again times pi, but plus pi r cubed over 1.5. 1.5, let's convert this into fraction form. Oh shoot, let me see here. Did I miss a negative sign somewhere? Oh, well, it doesn't really matter. So this would be 2/3. We'll revise this later, but this should look similar to you as negative 4/3 pi r cubed. And everything is correct except somewhere along the way I forgot to add a negative sign. Or maybe I misadded a negative sign. I'll try to find that. So this is the overall proof. Overall, it's good. It's just one negative sign. What? Where could I possibly go wrong? The fuck? Huh. Yeah, I do not know where to make the missing negative sign is. Yes. Yeah, you can just stop watching the video now. I think, God. God damn it, where's the missing negative sign? This is ridiculous. Wait, dx. You know, I give up. Hopefully you can comment below to see where exactly the negative sign was missed, but I just give up. My legs hurt. See ya.